4962. The first place ice is likely to form on an aircraft is the A. Wings, B. Tailplane, C. Windshield. The correct answer is B. Little and/or contract objects are the finest collectors of droplets and ice up most quickly. Usually why a little bulge inside locate of the pilot can be utilized as an ice-proof test. It is by and large one of the primary parts of the plane on which an obvious sum of ice shapes. An aircraft's tailplane could be a way better collector than its wings, since the tailplane presents a more slender surface to the airstream. 4964. If a pilot encounters freezing drizzle, he can assume that A. There is warmer air above. B. The freezing drizzle will accumulate as rime ice. C. Since freezing drizzle is supercooled, it is not a concern for structural icing. The correct answer is A. Freezing rain and freezing drizzle occur when the surface temperature is below freezing and the precipitation freezes on contact with the cooler surface. Ice associated with freezing rain or freezing drizzle can accumulate on and beyond the limits of an ice protection system. This kind of ice may not produce the familiar performance degradation. However, it may be hazardous. 4965. When flying through supercooled water droplets, the first sign of structural ice accumulation would be A. The leading edge of the wings. B. On probes and antennas. C. The windshield. The correct answer is B. When flying through supercooled water droplets, the first sign of structural ice accumulation is typically observed on probes and antennas, option B, rather than the leading edge of the wings. Probes and antennas, being small and exposed components on the aircraft, are particularly susceptible to ice formation. They are designed to measure various parameters such as airspeed, angle of attack, or temperature. These components often have small surfaces and intricate shapes that can easily collect ice. Due to their design and position, probes and antennas can encounter supercooled water droplets before other parts of the aircraft, such as the wings or windshield. As a result, ice can start to accumulate on these components first. 4966. What actions should the pilot take in the event of suspected tailplane icing during an approach? A. Leave the autopilot on to assist flying the approach. B. Use partial or no flaps and no autopilot. C. Hand fly the approach until the IAF and then use the autopilot. The correct answer is B. Tailplane icing can significantly affect the aircraft's stability and control, particularly during critical phases of flight, like the approach. To mitigate the risks associated with tailplane icing, the following actions are recommended. Use partial or no flaps. Adjusting the flap setting can help reduce the aircraft's pitch sensitivity and minimize the risk of tailplane stall or loss of control. Using partial or no flaps decreases the aircraft's nose-down pitching moment and provides a more stable configuration. Avoid using the autopilot. Engaging the autopilot during tailplane icing conditions is generally not recommended. Autopilot inputs can mask or delay the detection of control issues caused by icing. By hand flying the approach, the pilot can have more direct control and be able to sense any changes in aircraft behavior. 4967. Expect clear ice to form on the leading edge of airfoils when A. Liquid water and snow combine with ice. B. Temperatures are close to freezing. There is a large volume of liquid water precipitation and the aircraft is at high airspeeds. C. The precipitation is small droplets and the aircraft is at low airspeeds. The correct answer is B. Temperatures are close to freezing. There is a large volume of liquid water precipitation and the aircraft is at high airspeeds. Clear ice formation on the leading edge of airfoils is commonly associated with specific conditions. Temperatures close to freezing. Clear ice formation occurs when the temperature is near or slightly below freezing. In this temperature range, supercooled liquid water droplets freeze upon contact with the aircraft surfaces. Large volume of liquid water precipitation. The presence of a significant amount of liquid water in the form of rain or drizzle is necessary for the formation of clear ice. When there is an ample supply of liquid water in the air, it can adhere to the airfoil surfaces and freeze, gradually building up clear ice. High airspeeds. Higher airspeeds contribute to the formation of clear ice. As the aircraft moves through the air, it encounters a larger number of supercooled water droplets. The impact and impingement of these droplets on the airfoil surfaces lead to the formation of clear ice.